You see, um, before we drift into the deeper questions tonight, let me ask you something. Something quiet. Something that might linger with you long after the words fade. What if the universe is not defined by what fills it, but by what doesn't? Because, well, when you step back and look at the cosmos as a whole, you begin to realize that the most dominant feature out there is emptiness. Not the glowing galaxies, not the spiraling stars, not the blazing nebulae, but the vast, silent space between them. And that's the thing. The more we learn, the more the universe reveals this strange truth. Under 5% of it is made of the familiar stuff. The atoms, the dust, the stars we know. Everything else is invisible. Dark matter, dark energy, real, measurable, shaping the fate of the cosmos, yet forever hidden from our eyes. So I find myself wondering again, and, perhaps you do too. Why is the universe so astonishingly empty? And what does that emptiness say about our future? About the tiny moment in cosmic history when stars still shine and galaxies still sit close enough for us to see them? It's not just a scientific question, it's a deeply human one. Because in that vast darkness lies the story of where we're heading and what the universe will one day become. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. And, since we're sharing this quiet journey through the cosmic dark, tell me, where are you listening from tonight? It's always fascinating to see who's joining us from all around the world. So let's continue. And, when you look up at the night sky, really look, I mean, you begin to sense something subtle, something that sits beneath the beauty of the stars themselves. Well, the sky appears full, scattered with points of light like seeds drifting across a cosmic field. But you see, the more we've learned, the more we've mapped, the more we've reached into the deep darkness with telescopes and mathematics, the more we've discovered a quiet, almost unsettling truth. The universe is mostly empty. Not just empty in the poetic sense, empty in the scientific sense. The galaxies we admire, the spirals and ellipticals, the star clusters and glowing nebulae, are not the fabric of the cosmos. They are the embroidery, the lacework, the bright threads tracing the edges of something far larger, far darker, far more mysterious. And that is where this story begins, with the strange realization that the universe is not uniform. It's not a smooth spread of stars drifting evenly through space. It is a web, a vast cosmic network, delicate but immense, stretching across billions of light years. So, the natural question is, how does a universe that begins almost perfectly smooth end up looking like this, like a three-dimensional spiderweb spun from galaxies? Well, you see, everything starts in the aftermath of the Big Bang. In those first moments, the universe was a hot, expanding sea of particles, radiation, and energy. Almost completely uniform, yet not perfectly so. That almost is the key. Because tiny fluctuations in density, ripples only 1 part in 100,000, were already there. Imprinted by quantum processes magnified during cosmic inflation. And, these tiny fluctuations would become the seeds of everything. Regions just slightly denser than their surroundings would begin to pull more matter toward them. Gravity is patient. Gravity is relentless. Gravity does not need much to work with. But gravity alone isn't enough to explain the structure we see today. If we relied only on normal matter, atoms, protons, Neutrons. The early universe's pressure from radiation would have smoothed everything out. So the universe needed something else, something invisible, something heavier, a silent partner, dark matter. Well, dark matter is the scaffolding of the cosmos. It forms halos, vast, invisible spheres of mass, long before the first atoms could clump into stars. These halos shape the cosmic web. They pull gas along filaments, building the great walls and threads of matter we see in every large-scale survey. And perhaps this is one of the most beautiful things in cosmology. The idea that everything luminous in the universe, the stars, the galaxies, the clusters, is drawn along invisible lines, like frost forming along the unseen branches of a tree. And when we observe the universe on its largest scales, through surveys like the Sloan Digital Sky Survey, we begin to see this web directly. Not with the naked eye, but through maps, grand cartographies of existence, where galaxies form bright traces of the underlying structure. They cluster along filaments stretching hundreds of millions of light years. They gather in nodes, enormous superclusters where the web's threads meet. And between them lie the voids, vast cosmic hollows, dark and nearly empty. So, the universe is not a cloud of galaxies. It is a network of them. A network shaped by those primordial fluctuations, sculpted by gravity, and amplified by dark matter. Well, imagine stretching a sheet of fabric so that tiny wrinkles begin to grow. The wrinkles deepen. Some regions thicken, others thin. Matter flows into the deeper folds, slowly, inexorably. Over billions of years, those folds become filaments. The surrounding planes become the voids. It's not just poetic imagery. It's the mathematics of structure formation. The cosmic web is the result of matter falling into the deepest gravitational basins carved by dark matter. And, there's something astonishing about this web. Something deeply human in its mystery. Because once we map it, once we see the intricate lacework of galaxies scattered across the darkness, we cannot help but feel small, not diminished, but humbled. We grow older, clocks tick, and the universe reveals more of itself, always larger, always more complex, always more beautiful than the last time we looked. And perhaps what's most surprising is how little of the universe's mass is actually involved in the luminous part of this structure. Less than 5% of everything. The rest, dark matter and dark energy, makes up the true foundation. But even with only that 5% visible, the web emerges clearly. Look at the Sloan Digital Sky Survey maps, and you see threads spanning hundreds of millions of light years. Look deeper, and you find structures like the CFA Great Wall or the Hercules Corona Borealis Great Wall. The cosmic architecture is breathtaking in scale. And, well, all of this emerges from the tiniest initial imperfections. The universe is a masterclass in feedback. Small things grow into large things. Tiny ripples become continents of galaxies. The slightest excess of mass in one region becomes a gravitational empire. The cosmic web also tells us something profound about time. Because when we look at it, we are not seeing structure as it is now. We are seeing fossil imprints of how the early universe arranged itself. Light travels slowly across billions of light years. So the web becomes a time machine, a frozen snapshot of ancient gravitational battles. It's not out there. It's in here, in the way the past speaks through the light that reaches us. And, these threads are not permanent. As the universe expands, accelerating under the influence of dark energy, The web stretches. Filaments thin. Galaxies drift. Over immense timescales, the cosmic web will begin to tear. Regions that are now connected will slip beyond one another's horizons. So, the web we see today exists in a rare cosmic window. A brief moment when gravity has had time to pull structures together, but dark energy has not yet torn them apart. This makes our era cosmically special, not because we are central, but because the universe allows us to observe its grand design before it fades into loneliness. And, well, as we stand at this intersection of seeing and unseeing, of structure and emptiness, one truth becomes unavoidable. The cosmos is shaped not by fullness, but by contrast, by presence and absence, by filaments and voids. The galaxies cling to the threads. The threads outline the emptiness. The emptiness gives shape to the whole. It's not that the universe lacks matter. It's that matter has a map to follow, written in the language of dark matter and gravity. And perhaps that is the quiet wonder behind the cosmic web. It transforms emptiness into architecture. It turns almost nothing into something grand. And now, well, having traced the bright threads, the next step is inevitable. To understand the universe fully, we must turn toward the dark oceans between the filaments, the voids themselves, those vast hollows that dominate the volume of the cosmos. So, let us walk gently into that darkness next, into the silent regions where galaxies grow lonely, where density thins to almost nothing, where the universe shows us that emptiness is not a failure of creation, but a consequence of it. And, if the cosmic web is the grand architecture of the universe, then the voids, the vast hollows between its threads, are the silent halls between the pillars. Well, you see, when we finished tracing the filaments and walls at the end of the previous chapter, it was almost inevitable that our curiosity would drift toward the darkness between them. Because that space is not simply empty in the casual sense, it is profoundly empty. Emptier than anything we can experience on Earth, or even imagine intuitively. And that is the strange realization. Most of the universe is not galaxies, not stars, not nebulae, not clusters. It is emptiness, voids, caverns of near nothingness spanning tens, even hundreds of millions of light years. So, let us step softly into that darkness, not with fear, but with wonder. And, well, a cosmic void is not a vacuum in the absolute sense, of course. Even the emptiest regions of the universe contain a few atoms per cubic meter. But compared to the densest clusters, compared to the bright nesting of galaxies along the filaments, these voids are almost weightless seas. Their density is so low that if you averaged matter across one, you'd find only a tiny fraction of the cosmic mean. It's not just that they are empty, it's that they dominate. Voids make up most of the volume of the universe. Imagine a sponge, or perhaps a loaf of bread full of holes. The solid parts, the filaments and walls, are impressive and intricate, but the majority of the structure is the hollow space between them. That is our universe, a cosmic loaf where the emptiness defines the shape just as much as the matter. And, these voids form naturally in every simulation we run. You could take the LCDM model, that elegant combination of dark matter, dark energy, and general relativity, and let it evolve from the early universe onward, and the voids emerge on their own. They grow because the denser regions, shaped by dark matter halos, pull in material. Gravity gathers matter into filaments and nodes, leaving behind regions that are drained. Voids expand not because something pushes them outward, but because everything around them is pulled away. And that is one of those beautiful ironies of cosmology. Emptiness grows by subtraction. It is carved out by the gathering of everything else. So, how large are these voids? Well, typical ones stretch tens of millions of light-years across. Some balloon to 200, 300 million light-years. These voids are not small gaps between filaments. They are cosmic states unto themselves. And, when astronomers map them, using galaxy surveys like the Sloan Digital Sky Survey, they appear as vast spherical or elongated hollows. Not perfectly symmetric, of course. Nothing in the real universe is perfect. But their presence is unmistakable. What is astonishing is how smooth they are. While the filaments are turbulent, full of clusters and substructure, the void interiors are calm. The density fluctuations inside them are tiny. Galaxies there are rare, lonely travelers drifting far from their neighbors. Some voids contain only a handful of galaxies scattered like faint embers in a dying fire. It's not that galaxies cannot exist in voids. They do, but they evolve differently. With little external pressure, low-density environments, and almost no gravitational harassment from neighbors, void galaxies are often small, unusually blue, and slower to form stars. They are the quiet introverts of the cosmos. And, perhaps one of the most poetic aspects of cosmic voids is the silence they represent. Not literal silence, of course. Sound cannot travel across such emptiness, but an existential silence, a silence of isolation, a silence of distance. If a civilization lived inside a large void, their night sky would be almost empty. Only a few faint galaxies scattered across the cosmic darkness. They might never suspect that filaments and clusters exist at all. That in itself is humbling. Our picture of the universe depends entirely on where we stand. So, why do voids form the way they do? It all traces back to those primordial fluctuations. Regions that began just slightly underdense, perhaps only 1 part in 100,000, expanded faster than their surroundings. That tiny difference, magnified over billions of years, becomes a spherical gulf hundreds of millions of light-years wide. And, while gravity pulls matter into the dense regions, the underdense regions effectively relax. They stretch. They become the cosmic equivalent of low-pressure systems, rarefying further as the universe expands. The surprising thing is that voids are not static. They evolve. They merge. 2 neighboring voids can grow into one another, forming supervoids, massive hollows even larger than the typical ones. These are the desert continents of the universe. But before we drift into the supervoids and their extremes, it's worth pausing here, inside the ordinary voids, and thinking about what they tell us. They reveal something fundamental about the nature of the cosmos. Order emerges from contrast. Structure forms where matter gathers, and emptiness expands where matter flees. It's not a universe built only from stars and galaxies. It's a universe sculpted by absence, and, that absence gives shape to the whole, just as silence gives shape to music. Perhaps this is the most Brian Cox-like thought of all. The voids remind us that existence is defined as much by what is not there as by what is. They show us that the universe is not a crowded place. It is a vast and lonely ocean where islands of light float on a dark sea. And, there's another layer to this emptiness. Voids are not only large, they are dynamically important. As the universe expands, voids expand even faster. They push against filaments, stretching the threads of galaxies taut. Some call this the void phenomenon, the idea that the dominant driver of cosmic dynamics is not the dense regions, but the empty ones, growing silently in all directions. This leads to a fascinating perspective. The universe becomes more void-like as time goes on. Matter continues to flow into filaments, and the voids drain further. We are living in a cosmic moment when the web is still distinct, when the contrast is sharp. But in the distant future, the filamentary structure may thin. Voids may swallow more of the cosmic expanse. So, the universe is not only mostly empty now, it is becoming emptier with every passing moment. And, it's worth stepping back and imagining the future from the perspective of the void. What happens when a void grows large enough? What happens when these hollows begin to merge into the supervoids that hint at the next chapter? Well, you see, that's where the story naturally turns next, because among the many voids scattered across the universe, a few stand out. Giants among giants. The Botas void, for instance, a cavern so large and so empty it once defied belief. If the ordinary voids are deserts, then the supervoids are oceans. Their emptiness challenges our intuition. Their scale bends our imagination. And their existence brings us closer to the question of how such enormous hollows emerged in a universe that began almost perfectly uniform. And perhaps that is the gentle cliff we stand on now, looking from the edge of ordinary voids toward the realm of the extraordinary. So, let us drift into that deeper emptiness next, into the supervoids, into the rare extremes, into the cavities so vast that even astronomers whisper their names with a kind of reverence. And, when we drift from the quiet emptiness of the ordinary cosmic voids into the realm of the extraordinary, there is a faint sense, that we are crossing some invisible boundary. Well, voids themselves are already immense, already difficult for the human mind to hold in a single mental picture. But then we encounter something even stranger, something so vast, so empty, so improbable at first glance that it inspires both awe and a kind of scientific disbelief. The supervoids. The most famous among them, of course, is the Botas void. And, well, the Botas void is not just a void. It's not merely an empty patch. It is a cavern in the cosmic web so enormous that when it was first discovered in the early 1980s, astronomers genuinely wondered whether it might break the rules of our cosmological models. That is the power of scale. It forces us to rethink what we believe we understand. Imagine a region of space almost 300 million light-years across, an expanse so large that, were the Milky Way placed at its center, not another major galaxy would appear for hundreds of millions of years of travel. A darkness so vast that the nearest bright galaxies are mere specks flickering at its distant walls. This is the Botas void, a cosmic desert on a scale that defies everyday intuition. And, when it was mapped more carefully, astronomers found only a few dozen galaxies in this colossal region, a volume that, if it matched the average density of the universe, should have contained thousands. So, what are we to make of such emptiness? What kind of process could hollow out a region of space on such a monumental scale? Well, the first instinct might be to imagine an anomaly, something exotic, something that violates our theories. But the beauty of cosmology lies in its patience. The Botas void is extreme, but not impossible. its existence does not break the standard model of cosmology. Instead, it represents the most dramatic example of a natural process: the growth and merging of underdense regions over billions of years. To understand this, imagine multiple smaller voids forming early in cosmic history. Each begins as a region with slightly lower density than average, a small dip in the primordial field of fluctuations. As the universe expands, these underdense regions stretch, expand, and gradually merge like soap bubbles, combining into larger bubbles. Over cosmic timescales, these merged voids can form supervoids hundreds of millions of light-years across. It's not that the Bode's void must have formed from one enormous underdensity at the dawn of time. It could be, quite elegantly, the result of many smaller voids growing together. And that realization is strangely comforting. The cosmos, even at its most extreme, plays by its own rules. But the Bode's void still carries an aura of mystery, not because it contradicts physics, but because it forces us to confront the enormity of cosmic emptiness. The galaxies inside it are not only fewer, they seem almost accidental, sparse, isolated, drifting through an ocean devoid of gravitational companionship. Well, imagine living in such a galaxy. Imagine looking at the night sky from a world within the void. The Milky Way's sky is rich. Billions of stars, glowing dust lanes, nearby galaxies hovering at the edge of visibility. But inside the Bode's void, the sky would be darker, colder, lonelier. A handful of galaxies would speckle the cosmic distance. Entire superclusters would be forever out of sight. You would not know the universe had a web at all. And, this perspective brings us to a subtle but profound idea. The cosmic environment shapes what any civilization, anywhere, would think the universe is. Your cosmology depends on your cosmic neighborhood. Astronomers have even speculated, lightly, cautiously, that intelligent life in deep voids, if it exists, might never discover the true structure of the cosmos. Their telescopes would see darkness in nearly every direction. Their models might conclude that the universe is mostly empty and always has been. That is perhaps the most humbling thing about the supervoids. They remind us that our perspective, on our little planet, in our modest galaxy at the edge of a filament, is not universal. We see what our environment allows us to see. And, well, the Bode's void is not the only one of its kind. Astronomers have discovered others, some smaller, some larger, each shaped by the same underlying physics. There is the Eridanus supervoid, sometimes controversially suggested to coincide with the cold spot in the cosmic microwave background. There are immense low-density basins scattered across the Sloan survey maps, voids within voids, hollow spaces merging across cosmic expanses. But none have captured the scientific imagination quite like Bode's. Perhaps because it was one of the first, perhaps because of its scale, or perhaps because its discovery came at a time when our picture of the cosmic web was still forming, and this cavern of darkness seemed to challenge what little we understood. It's not that we were wrong about the universe. It's that we were only beginning to listen to its deeper mathematics. And, the more deeply we study supervoids, the more they reveal. They influence how galaxies evolve inside them. They alter the gravitational flow of matter on large scales. They shape the anisotropies in the cosmic microwave background. They act as subtle gravitational lenses, weak but measurable. And this is one of those surprising facts. Even emptiness has gravity. A void, being underdense, expands faster than the surrounding universe. It pushes outward. It stretches space. It affects the motion of galaxies at its boundaries. So, the Bode's void is not just a passive emptiness. It is an active structure, dynamic, evolving, participating in the cosmic dance. And, well, this makes the universe feel even more alive in its own quiet way. Not alive in a biological sense, of course, but alive in movement, in transformation, in the slow reshaping of space-time. And when we think about the voids, and especially the supervoids, we cannot help but wonder about the earliest instance of the universe, because these enormous structures whisper something about those primordial fluctuations. They must have contained dips deep enough, stretches broad enough, to allow such a cavern to grow. That brings us back to the cosmic beginning. The ripples seeded in those earliest moments still echo across billions of light years. And, perhaps that is why Bhutas feels special. It is not just empty, it is ancient. A fossil of the early universe, grown to impossible scale. And as we stand metaphorically at the edge of this cavern, gazing into darkness where galaxies are few and far between, we feel a gentle tug toward the next great force shaping these regions. Not gravity, not dark matter, not primordial fluctuations alone, but something even more pervasive. Well, you see, the voids, the supervoids, the thinning of cosmic structure over time, all of them led naturally to the influence of dark energy, the quiet, invisible pressure that accelerates the expansion of the universe. And, well, in a cosmos driven ever outward, the voids will only grow larger. The emptiness will deepen. The filaments will stretch thinner. And the Bode's void, vast as it is, may one day be only a modest hollow in an even greater darkness. So, perhaps this is the moment to turn our gaze from the structures carved by gravity toward the expansion driven by the dark energy permeating space itself. To ask what force is making the universe more empty with every passing epoch. And, that brings us gently to the next chapter, toward the mystery of the force that pushes everything apart. And, as we step away from the quiet immensity of the supervoids, those vast hollows carved by gravity and time, there's a moment where we begin to sense another presence in the cosmic story. Well, not a presence in the ordinary sense, not a particle, not a force we feel on our skin, but something quieter, subtler, and yet more dominant than anything we have encountered so far. You see, somewhere beneath the filaments, beneath the voids, beneath the drifting galaxies themselves, something is pulling the universe apart. Or rather, something is pushing it apart. And, well, this is where dark energy enters the conversation. The invisible conductor, the silent accelerant. The reason the vast empty regions of the cosmos grow even emptier with every passing epoch. It's strange to think that we did not always know the universe was accelerating. For most of human history, and even most of modern astrophysics, the assumption was simple. The expansion that began at the Big Bang should slow down. Gravity should act like a cosmic brake. So, imagine the shock in the late 1990s when astronomers studying distant supernovas discovered something astonishing. The universe was not slowing down. It was speeding up. Well, that discovery, quiet, careful, rooted in careful measurements, changed cosmology forever. Because if the universe accelerates, something must be driving that acceleration. Something must be woven into the vacuum itself. And, that something is what we call dark energy. The name is misleading, of course. Dark energy is not a substance in the familiar sense. It is not like dark matter, which forms halos and filaments. Dark energy is more like a property of space. You stretch space, you get more of it. You get more space, you get more dark energy. It's not energy inside space. It's energy of space. And, well, when space expands, dark energy does not dilute like matter does. Matter spreads out. Radiation thins, but dark energy remains constant in density. So as the universe grows, the proportion of dark energy rises. And as the proportion rises, the acceleration strengthens. This is what transforms the cosmic web. Not just gravity pulling galaxies into filaments, but dark energy stretching the voids between them. The filaments are like threads of dew on a spider web at dawn. At first, connected. At first, dense. But as the morning warms and the web dries, the strands thin, the droplets drift apart, and the gaps widen. So, imagine that on the scale of the cosmos. Galaxies are the droplets. Filaments are the threads. The voids are the growing spaces between. Dark energy warms the universe. Dark energy stretches the threads. Dark energy deepens the emptiness. And, that is perhaps why the supervoids are only the beginning. They are not anomalies. They are previews. What we see today, the Boötes void, the Eridanus supervoid, those enormous hollows in the cosmic web, are the opening notes of a deeper transformation. Dark energy ensures that the emptiness grows relentlessly, not because matter moves away faster than light, but because space-time itself expands. It's not the galaxies rushing through space. It's space unfolding beneath them. And, well, this is the part that feels almost philosophical. Because when you think about it, dark energy changes the meaning of distance. The light from distant galaxies stretches. The wavelengths lengthen. The galaxies appear dimmer, not because they fade, but because the fabric between us grows. And this stretching is not linear. It accelerates. It compounds. Every moment creates more space than the moment before. So, picture the future of the cosmic web. Filaments thinning, clusters drifting, voids swelling, supervoids merging. Until one day, far in the future, most galaxies drift beyond our cosmic horizon. Not because they move away from us, but because the expansion outruns their light. Well, that leads to a strange, almost uncomfortable thought. The universe we see today is temporary. It's not a static sky. It's a sky in the act of vanishing. Dark energy is the agent of that vanishing. It doesn't destroy galaxies. It isolates them. It's not a violent force. It's a lonely one. And as voids expand, as supervoids swell into something even larger, the universe becomes more fragmented. Regions that once shared gravitational influence become strangers. Galaxies that once fell toward one another instead drift apart, slowly, silently, eternally. And, this cosmic acceleration explains more than just the growth of voids. It explains why the cosmic microwave background appears as it does. It explains why the large-scale structure settles into the shapes we see. It explains the geometry of the universe itself. Imagine a graph of cosmic expansion. The curve bends upward. The universe accelerates. The emptiness grows. And gravity, which once sculpted everything, slowly loses its grip. Not entirely, but locally. Within clusters. Within groups. Within gravitational islands. It's not the end of structure. It's the end of connection. And, Well, this acceleration is more than a mathematical curiosity. It shapes the fate of everything, because the more the universe expands, the more isolated each region becomes. In the far future, so far ahead that even the stars will have aged beyond memory, each cluster of galaxies will exist alone in a sea of ever-growing darkness. And this is the paradox of dark energy. It gives the universe more space, but less togetherness. It fuels expansion, but extinguishes connection. So, what does that mean for the cosmic web, for the voids, for the supervoids? It means that everything we see now is a transient balance between gravity and expansion. Gravity builds structure. Dark energy dissolves it. Gravity gathers matter. Dark energy stretches the gaps. The universe grows emptier not just because voids exist, but because dark energy nurtures them. And, this brings a kind of poetic melancholy. We live in a moment when the cosmic web is still intact, when galaxies still cluster, when starlight still crosses the void, when the universe is still map-like. But in the deep future, and we're talking trillions of years, the cosmic web will unravel. The filaments will thin beyond recognition. The voids will widen until they dominate nearly everything. It's not the death of the universe. It's the quieting of it. And, well, if dark energy continues as it is, the expansion will keep accelerating. If it increases, the universe could even tear itself apart in a hypothetical big rip. But that is speculation. The simplest explanation, the one supported by the data, is that dark energy remains constant, a quiet and steady pressure. This steady pressure ensures a future cosmos of islands, galactic islands, each cluster alone, each group cut off. And that, oddly enough, sets the stage for the next chapter. Because if dark energy drives everything apart, if galaxies drift away faster than their light can reach us, then there must exist a boundary, a cosmic limit, a final horizon, the event horizon of the expanding universe. So, let us move gently toward that idea next. The idea that the cosmos has a distant edge, not in space, but in time. A boundary beyond which light will never reach us, drawn by the accelerating growth of space-time itself. And, there, in that fading light, we will understand what the future sky will look like. And, when we ended our last thought there, standing at the edge of the accelerating universe, watching space itself stretch beyond the reach of its own light, it felt as though we had reached a kind of boundary. Not a wall, not a surface, but a threshold, a horizon, a place where the universe whispers, softly but firmly, no further. Well, this idea, the cosmic event horizon, is one of the most haunting concepts in modern cosmology. You see, it isn't a horizon like the ones you and I know on Earth. It isn't the distance at which mountains appear to sink under the curvature of the planet. It is something deeper, something woven into the expansion of space-time itself. And the strangeness begins here. The universe expands so quickly that some regions recede from us faster than light. And that's the thing. It doesn't break any laws of physics, because it isn't the galaxies moving through space at superluminal speeds. It's space itself that grows. So, imagine a galaxy far away, its light stretching toward us, the wavelengths becoming longer, redder, thinner. And imagine that while the photon travels, the space between us expands faster than the photon can cross it. That light will never reach us. That galaxy will never be seen. It's not hidden behind anything. It's not out there. It's simply beyond a boundary defined by time and expansion. And, well, this cosmic event horizon is not fixed. It shifts as the universe expands. But its existence tells us something extraordinary. There will come a time when most of the universe becomes unobservable, not metaphorically, literally. The information it carries, the starlight, the structure, the history, will be forever out of reach. Imagine the sky of the far future, where ancient galaxies once glimmered. There will be nothing but black. Where clusters once formed fractal networks of light, there will be silence. The observable universe will shrink, not in size, but in content. So, what is this horizon? It is the boundary between what can influence us and what cannot. Between the knowable cosmos and the unreachable. Between the universe of today and the universe of tomorrow. And, to understand it, you and I must revisit a simple but deceptive idea. Distance. Well, distance in everyday life feels stable. A kilometer is a kilometer. A meter is a meter. But the cosmos operates differently. As space stretches, distances grow. And as they grow, the definition of what is reachable changes. It's not the distance that matters. It's the rate at which that distance grows. A galaxy 10 billion light-years away might still be visible. A galaxy 5 billion light-years away might not. Because what determines visibility is not size, but destiny. And this is where the cosmic event horizon reveals its unsettling truth. Light we will never receive is being emitted right now. Entire galaxies, entire clusters, entire webs of matter are speaking, but we exist outside the window where their voices can reach. And, well, this means something quietly profound. The universe we observe is not the universe that exists. It is the universe whose past light has managed to reach us in time. So, what is inside the event horizon? Everything we can ever study, everything we can ever learn, everything that will ever be part of our cosmic story. And what lies beyond it? An ocean of unreachable reality. A library whose books we can never open. A sky whose light is forever lost. This horizon is closer than we might expect. Roughly 16 billion light-years in proper distance. Beyond that, galaxies are slipping away faster than their photons can compensate. And each passing moment expands the boundary of loss. We grow older, clocks tick, and the universe offers us less of itself. And, the horizon also offers a surprising insight. The observable universe will, in a sense, contract in terms of information. Not because we shrink, but because everything else accelerates into darkness. Well, imagine future astronomers, trillions of years from now, looking out into the night. They will see only the galaxies gravitationally bound to them. Perhaps only the merged remnant of the local group. No cosmic microwave background. No large-scale structure, no filaments, no voids, no superclusters. It's not cosmic ignorance. It's cosmic isolation. And, well, they might come to a startling conclusion that the universe is static, that it contains only a small island of stars, that the cosmos is finite and quiet. They would be wrong, but they would have no way to know. And this raises a delicate question. If most of cosmic history becomes unobservable, what does that mean for knowledge? For our understanding of the universe? For the legacy of cosmology itself? So, look at where we stand. In a fleeting era where the universe is still illuminated by galaxies whose light is just barely able to reach us. In an age where the cosmic microwave background still glows as a faint whisper, in a moment where the large-scale structure is still visible. And, this moment will not last. The horizon creeps closer. The observable sky thins. The stars drift away in silence. But perhaps that fragility is what makes our time so meaningful. We live in a universe that allows itself to be known only briefly. Knowledge is not guaranteed. It is a privilege of timing. And we should pause here, at this horizon, because the idea carries another implication, one woven into the deepest questions of existence. If cosmic expansion isolates galaxies, if the horizon limits visibility, if information fades into darkness, then what does it say about the search for life? About Fermi's paradox? About the quiet that blankets the cosmos? It's not. It's not simply that we haven't heard anything. It may be that we can't, or that signals never had enough time to cross the growing gulf, or that distant civilizations, like distant galaxies, have already drifted beyond the horizon. And, that thought leads naturally, almost inevitably, into the next chapter. Because while the event horizon tells us what we cannot see, Fermi's paradox tells us what we have not yet seen. And those two silences, the cosmic and the biological, may be more intertwined than we think. So, let us walk toward that silence next. Toward the question that lingers at the edge of physics, astronomy, and human longing. If the universe once brimmed with light, and if time will one day hide that light forever, then what about life? What about voices? What about minds looking back? And, in the growing emptiness shaped by gravity and dark energy, where have all the others gone? And, as we step out of that fading light, where galaxies slip beyond the cosmic horizon and silence settles across the widening void, there's a question that lingers, almost painfully, almost insistently, in the human mind. You see, when we gaze into that dissolving darkness, we can't help but whisper it to ourselves. If the universe is so vast, so old, so rich in stars and planets and possibilities, then where is everyone? This is the heart of the Fermi paradox, a paradox born not from equations, but from intuition, not from observation, but from its absence. And, it is tempting to fill that silence with stories, with fantasies, with dark forests and hidden watchers. But science offers a gentler path, a quieter explanation rooted not in fear, but in physics. Because the more we understand about voids, about acceleration, about horizons, the more the silence begins to make sense. It's not that the universe refuses to speak. It may be that its voices never could reach us in the first place. So, let's sit with that for a moment. The silence might not be emptiness. The silence might be distance. The silence might be time. And, time matters more than we think. Civilizations rise and fall in cosmic instants. Stars ignite and extinguish across billions of years. Signals weaken, scatter, dissolve into the background hiss of the universe. A message sent early may arrive when no one remains to hear it. A message sent late may never outrun the expansion of space. And the paradox becomes softer when viewed this way. Less an accusation, more a reminder of scale. Because when we ask why we haven't heard from anyone, we forget that the universe is not static. Its galaxies are not neighbors in any meaningful sense. They drift apart, held only by gravity within small groups, while all beyond slips away. And, Imagine a civilization on a distant world. Imagine their first radio signals, random, weak, lost in the electromagnetic noise of their own planet. Imagine their later signals, more coherent, more intentional, perhaps even directed outward. It doesn't matter how powerful they are. It doesn't matter how curious. It doesn't matter how long they transmit. If they are too far, their messages stretch, redshift, flatten into nothing. Distance consumes intent. Expansion consumes information. And so we begin to realize something important. We aren't listening to a quiet universe. We're listening across a chasm that widens faster than any technology can cross. The paradox dissolves when the scale becomes clear. And, this also reframes another familiar thought, that advanced civilizations must spread across the stars, colonizing galaxy after galaxy. But even this assumption may crumble under the weight of cosmic dynamics, because colonization requires time, and time is shaped by distance, and distance, well, distance is shaped by expansion. So, even a civilization that grows, expands, thrives, might never reach far beyond its local group of galaxies, not because of failure, not because of catastrophe, but because the universe itself sets limits. It's not a prison, it's a horizon. And, well, this is where cosmology touches something deeply philosophical, because we tend to imagine life as a universal phenomenon, something that should echo across the cosmos. But what if life is local not by rarity, but by necessity? What if every civilization is, by cosmic design, an island? And the waves between islands are not seas. They are expanding space-time. So, perhaps the silence is not evidence of loneliness. Perhaps it is simply the shape of the universe. And, to see how this plays out, consider the lifespan of a technological species. 100,000 years? 1,000,000? Even 1,000,000,000? On cosmic scales, it's the blink of an eye. And communication, real, two-way communication, requires simultaneity. Civilizations must overlap not only in space, but in time. The universe is too old for easy overlap. The stars too numerous. The distances too vast. We might be aligned with none, aligned with no one, aligned with nothing but the night. And, well, the lesson becomes clearer still when we think about how signals behave. Electromagnetic waves weaken with distance. They disperse. They lose coherence. The cosmic microwave background noise increases relative to the signal. Even a powerful beacon becomes indistinguishable from randomness after enough billions of light years. It's not that no one sends. It's that no one arrives. And then there is the event horizon, the ultimate boundary of communication, a distance beyond which messages cannot cross, no matter how long the universe endures. And, well, with every expansion, with every moment of cosmic time, more and more galaxies slip beyond that horizon. More and more potential civilizations become permanently unreachable. So, the silence we hear today might be the echo of a deeper truth, that the cosmic window for interstellar and intergalactic communication is narrow, and we are living within it, but only barely. The horizon tightens, the universe accelerates, the voices fade, and, all of this leads us, slowly, gently, to reconsider what the paradox truly asks. Perhaps the question is not why no one has visited, but whether anyone could. And perhaps the question is not why we don't see evidence, but whether evidence can survive across a universe that expands relentlessly, thinning signals until they dissolve entirely. In this light, the paradox becomes less paradox and more inevitability. Not just silence, but the physics of silence. And, well, that physics points toward a sobering conclusion. The more the universe accelerates, the more each galaxy becomes isolated. And isolation means that any civilization, no matter how advanced, eventually becomes cosmically alone. It's not the end of life. It's the end of contact. So, we stand here, at the midpoint of cosmic history, listening to a quiet universe, not because it lacks life, but because the laws of nature conspire to keep its voices apart. A universe where curiosity may be universal, but communication is not. And yet, despite all this, there is a strange and gentle beauty to the idea, because it reminds us that we are precious, that every mindful species is precious, a fleeting constellation of atoms that briefly contemplates the night before the night grows too wide to answer back. And, well, that brings us to an even deeper thought, one that points us toward the next chapter. If civilizations become isolated, then their galaxies too will drift into isolation. Gravity will hold only what is near. Everything else will fall beyond the horizon. So, let us turn now toward that cosmic future, toward the age when galaxies stop gathering, when only local gravitational families remain, and when the universe enters its long era of separation. And, that will take us gently into the next chapter, toward the future of galaxies in an ever-expanding, ever-quieting cosmos. And, when we left that earlier thought, the one about cosmic isolation, about the silent drift of civilizations and galaxies, we were already standing, almost unknowingly, at the edge of a new era. Well, you see, the universe is not static in its loneliness. It evolves into deeper loneliness. It changes shape in a way that slowly, gently, separates everything from everything else. And that transformation is written most clearly in the future of galaxies. Galaxies are not just ornaments in the sky. They are the grand islands of matter, the places where stars are born, where planets form, where chemistry begins to think about itself. And yet, as the universe expands faster and faster, their fates diverge. Some remain bound together, others drift into the unreachable dark. And, well, the key idea is this. Gravity has limits. Not emotional limits, of course, though we might poetically imagine it that way, but physical ones. Gravity binds only what is close enough, dense enough, massive enough. Beyond that threshold, the accelerating expansion wins. So, in the deep future, long after our present age, only small groups of galaxies will remain gravitationally connected. Local families, local clusters. Everything else will slip beyond the cosmic horizon. Take our own cosmic home. The Milky Way, Andromeda, and a scattering of dwarf companions form the local group. A small archipelago amid a vast and empty sea. And because gravity here is strong enough, these galaxies will remain together even as the universe expands. It's not that we will chase Andromeda, or that Andromeda will chase us. It's that gravity will pull us into one another. A slow dance, a merging of stars and dust and dark matter. And, in a few billion years, long after our sun has changed, the Milky Way and Andromeda will collide, merging into a new galaxy, sometimes called Milkdromeda, though the name hardly matters. It will be a giant elliptical galaxy, glowing faintly with the combined light of trillions of stars. And as this new galaxy forms, the rest of the universe will continue to drift away. Clusters we see today will vanish one by one. Voids will swell. The cosmic web will thin. The result is inevitable. The local group will become the only visible structure in the sky. And, well, imagine standing on a world trillions of years in the future. The night would not resemble our night. The Milky Way band would be gone. The galaxies we now observe in telescopes, scattered like rare jewels across the abyss, would have faded into invisibility long before. Their light, stretched by expansion, would redshift until it became undetectable. So, the future astronomers of that era, if such astronomers exist, will see only their own merged galaxy, only their local island, only their immediate cosmic neighborhood. It's not ignorance. It's the nature of the horizon. And, here is the heartbreaking twist. They will not see the cosmic microwave background either. Not because it disappears, but because it stretches. The wavelengths grow longer still, eventually so long that they cannot be detected by any conceivable instrument. We grow older, clocks tick, and the universe hides its origin. And, well, this concealment means that future beings, if they rely only on observation, will not be able to rediscover the Big Bang. They will not see the afterglow. They will not observe the large-scale structure. They will not detect the receding galaxies. The universe will appear static, eternal, quiet. It's not that the Big Bang didn't happen. It's that the evidence drifts away faster than curiosity can chase it. And, in this era of isolation, star formation slows as well. Gas becomes scarce. Hydrogen, the primary fuel, grows thin. Galaxies age. Red stars dominate. Blue stars, bright and short-lived, fade from cosmic history. The spirals lose their arms. Ellipticals grow smooth and featureless. New stars become rare. So, we enter what scientists sometimes call the degenerate era. Not in a moral sense, but in a physical one. A time when the universe no longer produces abundance. A time when it remembers rather than creates. And, well, the local group, by then fully merged, will persist as a lonely island in an expanding nothingness. The nearest galaxies will lie beyond reach, beyond sight, beyond meaning. It's not a tragedy. It is simply the aging of a universe. And if life still exists in that time, if some civilization defies extinction, if minds continue their long conversation with the cosmos, they will live in a universe very different from ours. A universe of solitude. A universe where cosmology becomes an act of imagination rather than observation. And, perhaps that is the most poetic element of all. We live in a privileged epoch, a time when the sky is bright with clues, a time when galaxies still speak to us, a time when the afterglow of the beginning still hums faintly across the microwave sky. So, what does that mean for us? It means that science, this act of listening, this act of wondering, has a deadline. Not tomorrow, not in 1,000 years, but written into the deep physics of space-time. The cosmic archive is slowly closing. And, well, this makes the present all the more precious. We are alive at the only time when the universe explains itself. And yet, even as we look toward that distant future, the era of merged galaxy islands, we find ourselves drawn further still. Because the tale does not end there. Galaxies grow quiet, but stars continue to burn. Stars continue to age. Stars continue to die. And the fate of those stars, the last embers, the final glimmers, that becomes the next chapter in this long cosmic unfolding. So, so, let us follow that faint trail next. From galactic isolation to stellar extinction, from the last bright suns to the age of darkness, and, beyond the merging galaxies, beyond the shrinking sky, we will listen to the slow heartbeat of the final stars as they approach the end of cosmic time. And, as we drift forward from that vision of isolated galaxy islands, there is a quiet hush that seems to settle over the cosmic stage. Well, you see, once the galaxies have merged into their small gravitational families, once the universe has stretched itself so thin that nothing outside those islands can ever influence them again, a new chapter begins, and the strange thing is that this chapter is not defined by abundance, but by decline. Stars begin to fade. Not suddenly, not dramatically, but slowly, rhythmically, like campfires running out of fuel long after the night has begun. And, well, the universe has always relied on hydrogen as its simplest note, its most primitive song. Hydrogen fuses into helium, helium into carbon, and so on. But the supply is not infinite. The great clouds that once gave birth to star-forming regions grow thin. Their reservoirs diminish with each generation of stars. So, star formation first slows, then falters, then ends. It's not that the universe forgets how to make stars. It's that the raw material is gone. And, in this future, only the long-lived stars remain. Sun-like stars burn through their hydrogen in mere billions of years. Massive stars last only millions. But red dwarfs, those dim, steady embers that shine with quiet persistence, live for trillions. They do not flicker boldly in the sky. They are not the blue supergiants that illuminate nebulae, but they endure. And for most of the universe's life to come, these red dwarfs will be the only lights in the dark. We might call this the era of endurance, the age of long twilight, and, well, eventually even these small stars run out of fuel. Their fusion slows, their surfaces cool, they contract, and one by one, across unimaginable spans of time, they dim into black dwarfs, stellar remnants that no longer shine. So, picture a sky that once held billions of stars. Now picture it with millions, then thousands, then only a handful, and then, finally, none at all. It's not the universe switching off. It's the universe exhaling for the final time. The only objects that still retain heat, that still glow faintly, are the remnants, white dwarfs, neutron stars, black dwarfs, and black holes. And for a while, though a while here stretches beyond numbers, these remnants form the architecture of the cosmos. And, this is where the physics takes on a subtle melancholy, because even these remnants do not last forever. White dwarfs cool. Neutron stars lose energy. Black dwarfs, though rarely mentioned, will eventually decay through processes that are so slow, so improbable, that we can barely wrap our minds around them. And then there are black holes. And, well, black holes might seem eternal at a glance. They swallow matter, distort space-time, and lock their secrets behind horizons that no force can escape. But we know now, thanks to Hawking, that even black holes radiate, slowly, quietly, almost shyly. So, imagine a universe that has been left to black holes alone. No stars, no galaxies, no visible light. Only the deep hum of space-time curving in on itself, punctuated by these invisible giants leaking away their mass one particle at a time. It's not violent. It's a long, soft fading. And some black holes, those formed from collapsing stars, will evaporate first. The supermassive ones at the centers of the merged galaxies will outlive all others. But even they will not survive eternity. They will take longer than we can meaningfully comprehend, but eventually their mass will diminish, their horizons will shrink, and they will evaporate into the cold background of the universe. And, when the last black hole evaporates, something astonishing happens. The universe becomes, in a very real sense, featureless. No stars, no planets, no black holes, no structure for gravity to shape. Only particles drifting in a vast, thin bath of almost nothing. So, we enter the final era, the heat death. And, well, the phrase itself carries a weight, but it does not refer to heat in the everyday sense. It refers to entropy, to the tendency of systems to move toward uniformity, toward stillness, toward a state where nothing interesting can happen. In the heat death era, the universe reaches maximum entropy, maximum disorder. But ironically, that disorder looks like silence. It looks like calm. It looks like a sky that has forgotten how to change. It's not tragic in the narrative sense. It is simply the end point of physical laws playing out. And, when we imagine this far future universe, we face an emotional tension. Because we live now in a universe that is rich with structure. We see stars. We see galaxies. We see light that traveled billions of years to reach us. But those future beings, if any persist, will see none of this. So, the universe will have shifted from a place of creation to a place of memory. Long after the last red dwarf fades, long after the final black hole evaporates, the universe will drift toward equilibrium, toward a state that no longer allows complexity, toward a cosmic darkness that is absolute. And, well, one might ask, is that truly the end? Whether it exists at all. A deeper layer beneath this story. Quantum fluctuations still exist even in the emptiest vacuum. Virtual particles still dance momentarily in the darkness. The vacuum is not truly empty. But these fluctuations do not form galaxies. They do not form stars. They do not form life. They are whispers, not symphonies. And yet, perhaps that is the quiet beauty of the far future universe. A universe stripped of grandeur becomes a universe of pure physics, where only the most fundamental rules remain, where only the fabric of space-time whispers to itself. The heat death is not an explosion, not an ending in fire, but an ending in stillness, a slow settling, a final quieting of the cosmic breath. And, here is the thought that lingers. We exist now, right now, in a moment when the universe is vibrant, when stars burn, when galaxies collide, when the cosmic microwave background still tells us the story of the beginning. We live before the silence. So, perhaps that is what makes our era meaningful. Not just the science we uncover, but the recognition that we stand in a fleeting window of cosmic time, a window that will never open again, a window where the universe is illuminated enough for minds to arise and wonder about it. And, well, as we follow the timeline forward, from star birth to star death, from black hole dominance to heat death, we also feel another subtle pull. Because the story is not finished, the universe still holds mysteries deeper than the fading of stars. And the next line in this cosmic tale carries us into the darkness beneath the darkness, to the invisible architecture shaping everything we see, to the substance that holds galaxies together, defines the cosmic web, and decides which regions remain full and which become empty. And, So as the stars fade into their final embers, we turn our attention to the thing that has guided the universe since the very beginning, the silent scaffolding of dark matter. And, as we drift away from that image of the universe cooling into silence, stars fading, black holes evaporating, there is a deeper question that begins to rise. Almost like a shadow taking shape behind the fading light. Because if the universe grows empty, if the voids deepen, if the galaxies fall apart into islands, then we must ask, what carved this emptiness in the first place? What shaped the cosmic web? What determined where matter gathered and where it withdrew, leaving behind those astonishing voids we explored in the earlier chapters? Well, you see, the answer is not the ordinary matter we know, not the atoms, not the stars, not the gas clouds or the planets. Those things, those familiar things, make up only a tiny fraction of the universe. We tend to think of the cosmos as made of the things we can see. But that is a misleading comfort. Because the structure of everything, the distribution of everything, the vast emptiness between everything, these are shaped by something we cannot touch or see. And, well, that something is dark matter. Dark matter is not dark in the sense of shadow. It is dark in the sense of absence of interaction, absence of light. It neither glows nor absorbs. It moves silently through galaxies, through stars, through us. And yet, paradoxically, it defines the architecture of the universe. So, let's imagine the early universe again, long before galaxies, long before stars, even long before atoms. A universe filled with ripples, tiny variations in density, slight fluctuations left over from the Big Bang. Ordinary matter responds to these ripples. Yes, but slowly, clumsily, because ordinary matter feels pressure, radiation, collisions. Dark matter, by contrast, passes through everything, collapsing into dense knots long before anything else can follow. And, this creates the scaffolding, the invisible web, the gravitational skeleton of the cosmos. Galaxies do not simply form anywhere. They form along this skeleton. They light up the intersections, the nodes, while the vast spaces in between remain empty because there is no dark matter there to pull matter inward. It's not that matter avoided those regions. It's that those regions never had the gravitational invitation to begin with. And, well, that means something profound. The universe looks empty not because material has been cleared away, but because the underlying structure was always uneven. The emptiness is not an afterthought. It is the original blueprint. So, when we stare into a large cosmic void, we are not seeing a region that was drained or evacuated. We are seeing a region where dark matter simply never collected. A region that never gained the mass needed to seed galaxies. A region that remains untouched by the cosmic architecture. The evidence for this is surprisingly clear, even though dark matter itself remains invisible. We see galaxies spinning too fast for their visible mass. We see gravitational lensing bending light around regions that contain no visible stars. We see the imprint of dark matter in the cosmic microwave background. Every observation points toward a vast unseen component sculpting the universe. And that is why the universe is so astonishingly empty. Not because matter failed, but because dark matter shaped a universe where emptiness dominates. And, if you step back, far back, into a cosmic perspective, a beautiful pattern emerges. The cosmic web forms filaments and walls, long strands of galaxies stretching across tens or hundreds of millions of light years. And between them are voids so vast, so silent, that entire clusters of galaxies could drift through without touching anything. It's not an accidental emptiness. It's the structural emptiness of a universe guided by invisible mass. And, well, this also means that dark matter has been guiding the story of the cosmos from the very beginning, shaping the peaks and valleys in which galaxies formed, stars lived and died, planets coalesced, and eventually, on at least one small world, life appeared. So, when we speak of the universe becoming emptier over time, when we talk about expansion, isolation, horizons, we are really describing a second layer of emptiness. The first layer was written by dark matter. The second is stretched open by dark energy. And, this dual emptiness gives the universe its character. Dark matter creates the structure. Dark energy dissolves the connections. Ordinary matter is merely the visible frosting on an invisible cake. And perhaps the most interesting thing is this. Dark matter determines not only where galaxies exist, but how they behave. It shapes their rotation curves, their stability, the thickness of their halos. Without dark matter, galaxies would fly apart. They would unravel into streams of stars drifting into the void. And, well, one could say, poetically, that dark matter holds the universe together even as dark energy pulls it apart. Creation and dissolution, binding and unbinding. Two great forces writing the cosmic narrative. So, if we imagine the universe without dark matter, the picture changes fundamentally. There would be no cosmic web, no clusters, no filaments, no voids, no galaxies at all. It's not merely an invisible substance. It is the architect of the universe. And this realization leads to an almost philosophical question. Does a universe built mostly from things we cannot see make our visible world more miraculous or more fragile? We grow older, clocks tick, and yet the invisible continues to define us. It's not out there. It's in here, woven into the structure of every galaxy we observe. And, when we return to the idea of cosmic emptiness, the theme running through this entire journey, we see dark matter in a new way. The emptiness exists because dark matter decided where not to be. The voids exist because dark matter never filled them. The cosmic web exists because dark matter clustered. And in the far future, when the universe fades into darkness, when stars die, when galaxies drift into silence, dark matter will still be there. Cold, invisible, unknowable, holding the remaining structures together until even gravity becomes too weak to matter. And, well, this also suggests something haunting. Even as the universe becomes colder and quieter, dark matter continues to act, to shape, to bind. It doesn't glow. It doesn't shine. It doesn't die. It simply persists. So, in a sense, the universe grows empty around a skeleton that refuses to disappear. The visible world fades. The invisible remains. And, this brings us, gently, inevitably, to the next great mystery. Because if dark matter sculpts the universe, if it governs the emptiness and the clustering, then there is one final question we must confront. What is the nature of the vacuum itself? In quantum theory, emptiness is not empty. It bubbles with virtual particles, fluctuations, energies that never settle. So, if the universe is shaped by invisible matter and dissolved by invisible energy, then perhaps the the very nothingness, holds the deepest secrets of all. And, well, that idea, that possibility, that the emptiness is not a void but a fabric, is where our journey must go next. And, so let us step quietly now into that final chapter, toward the quantum vacuum, toward the energy of nothing, toward the strange realness of the space between the stars. And, when we ended our previous thought, standing at the edge of the cosmic web, staring into the invisible scaffolding of dark matter, there was still something lingering beneath it all, something quieter, subtler, almost shy. The idea that beneath the voids, beneath the galaxies, beneath even the dark matter that shapes them, there is another foundation, a deeper layer of reality, a place where emptiness is not empty. Well, you see, this brings us into the strange territory of quantum physics, where intuition falters and the universe behaves in ways that feel more like whispers than laws. And the astonishing idea at the heart of it is this: even the vacuum, this vast, silent expanse we imagine between galaxies, is teeming with activity. The quantum vacuum is not a void. It is a stage where particles flicker in and out of existence, a stage where fields fluctuate even at their lowest possible energy, a stage upon which the entire cosmic drama is built. And, well, the way we often talk about emptiness is misleading. We imagine it as blank, as absence, as something like a cold room with nothing inside. But in quantum field theory, the vacuum is the lowest energy state of a field, not the absence of the field itself. And fields, the electromagnetic field, the Higgs field, the fields that guide quarks and gluons, are everywhere. They cannot be turned off. They define space itself. So, even in perfect darkness, even in perfect silence, something continues to move. It's not visible. It's not tangible, but it's real. These fluctuations, these ephemeral blinks of quantum energy, create virtual particles that appear and vanish faster than any detector can catch. But their effects accumulate. They shape forces. They push and pull. They give rise to measurable phenomena. The Casimir effect, for instance, the attraction between two metal plates placed incredibly close together, exists because the vacuum between them is active, not empty. And, well, this helps us understand a profound idea. The vacuum has energy. Vacuum energy, a baseline hum of the universe. It might be responsible for the cosmological constant, the term in Einstein's equations that describes the accelerated expansion of the universe. And that acceleration, as we know, is driven by what we call dark energy. So, the nothingness that fills most of the cosmos might actually be the fuel that causes the cosmos to expand. It's not emptiness. It's a creative pressure, a quiet, persistent stretching of space-time. And this leads to one of the greatest puzzles in physics. The quantum field calculations of vacuum energy predict a value so enormous, so breathtakingly huge, that if it were correct, the universe would have torn itself apart instantly after the Big Bang. The predicted value is, famously, about 120 orders of magnitude too large. 120. That is the most inaccurate prediction in the history of science. And, well, we don't know why. We don't know why the vacuum energy is so incredibly small compared to what quantum physics suggests. We don't know why it drives the expansion so gently instead of catastrophically. We don't know how quantum fluctuations scale up into cosmic acceleration. It's not a failure of physics. It's a sign that our understanding is incomplete. And that incompleteness is beautiful, in a way, because it means the universe is still deeper than our best equations, still stranger than our best metaphors, still more mysterious than our boldest imaginations. And, if we follow this thread further, we find that the vacuum might not simply be a background. It might be the very thing from which reality emerges. Quantum fields fill space. Particles are excitations of those fields. Even the Higgs field, which gives mass to fundamental particles, is a constant sea that fills the universe, shaping the behavior of matter. So, the vacuum is not the absence of reality. It is the foundation of reality. It's not nowhere. It's everywhere. And if we peer even deeper, through thought experiments, through mathematics, through the limits of what we can measure, we encounter another idea. Vacuum fluctuations may have played the central role in the formation of the universe itself. During the earliest fractions of a second, the universe likely experienced a period of rapid inflation. In this era, tiny quantum fluctuations in the vacuum were stretched to cosmic scales, seeding the density variations that would later form galaxies, voids, and the cosmic web. And, well, that means everything we see today, every star, every galaxy, every world, originated from quantum jitters in an almost featureless vacuum. So, when we talk about the emptiness of the universe, we're really talking about a creative emptiness, a generative emptiness, an emptiness that births structure. It's not absence, it's potential. And this changes the emotional flavor of cosmic emptiness, because the vast dark voids between galaxies are not simply empty holes. They are filled with fields, filled with vacuum energy, filled with the possibility of fluctuation. They might look silent, but their silence is layered. Quiet, yes, but never still. And, this also means that the future we imagined, the era of heat death, of black hole evaporation, of the final cooling of the cosmos, is built upon a vacuum that will continue to fluctuate forever. Even in the absence of particles, even in the absence of structure. And in that far future, the quantum vacuum may still hold surprises. Random fluctuations might occasionally produce particles. Rare events might create temporary pockets of order. Even entire new universes, according to some interpretations, might bud off from quantum fields. It's not certain, but it's one of the possibilities that arises naturally when the vacuum is not truly empty. And, well, this idea, this picture of emptiness as something rich, something textured, brings us full circle. We began with the observation that most of the universe is empty. We walked through voids, supervoids, galaxies, horizons. We watched the stars die and the cosmos cool. We stared into the skeleton of dark matter. And now we arrive at the final revelation. The emptiness itself is filled with physics. So, perhaps the universe was never defined by the things in it, but by the space between. Not just matter, but the fabric upon which matter floats. Not just galaxies, but the vacuum that gives them room to exist. And as we let this idea settle, something gentle happens. We begin to see ourselves differently. We grow older, clocks tick, but the vacuum beneath us remains. It supports the stars, it whispers through particles, it shapes the destiny of the universe. And, maybe that is the final wonder, that in a cosmos which seems empty, we find fullness, that in a universe which seems cold, we find energy, that in silence, we find motion. that in darkness we find the origin of light. And this quiet realization carries us naturally toward the closing of our journey. Not an ending, because the universe never truly ends, but a moment to pause, a moment to breathe, a moment to understand that we, too, are temporary patterns in a universe of fluctuations. And, well, as we step from the quantum vacuum toward the final reflection, we carry with us the sense that emptiness is not something to fear. It is something to marvel at, something that built us, something that will outlast us, and, So let us move gently now toward that closing thought, toward the rare golden moment in which we exist in a universe still young enough to shine. And, as we arrive at the quiet edge of this long journey through an almost empty universe, something soft settles in, like the faint hum of starlight stretched thin across billions of years. Well, you see, after wandering through cosmic webs and voids and horizons that slip forever beyond our reach, we begin to understand a truth that is both simple and overwhelming. The universe is not made of what we see. It is made of what we don't see. That is the strange poetry of it. The galaxies, the stars, the atoms that build our bodies. They are not the rule. They are the exception. We live inside a brief, luminous moment carved out of an ocean of emptiness. And somehow, that emptiness shapes everything. Perhaps the most humbling realization is that this vast cosmic loneliness is not a flaw in the universe. It is its structure. It is its destiny. The voids grow. The galaxies drift. The fabric of space-time stretches until light itself can no longer bridge the widening gaps. And the universe becomes quieter, and darker, and ever more remote. It's not that things disappear. It's that the space between things expands faster than their light can close. Not just a separation of distance, but a separation of time itself. So, when we look up at the sky tonight and see the Milky Way arcing across the darkness, we are witnessing a miracle of timing. We grow older, clocks tick, and yet, for this fleeting cosmic era, the stars are still burning, the galaxies still visible, the universe still whispering its early history to anyone listening. And, well, it won't always be like this. Far ahead, when the cosmic expansion erases our view of distant galaxies, when the cosmic microwave background stretches into silence, when stars fade into embers and black holes slowly evaporate in the cold afterglow of eternity, the universe will be a quieter place. Beautiful, yes, but in a way almost unimaginable to minds born in a universe still warm with starlight. The astonishing part is that we are here now, at the moment when the universe is knowable, at the moment when light from billions of years ago still reaches us, at the moment when the cosmos reveals its structure not just in theory, but in observation. And, that makes our existence not just improbable, but profoundly meaningful. Because science is not merely a collection of facts, it is a form of reverence, a way of listening to a universe that speaks in gravity and light, and the long echoes of primordial fluctuations. A way of understanding that the emptiness between galaxies is not a void to fear, but a canvas upon which the greatest structures of the cosmos are painted. It's not out there. It's in here, in the way we marvel, in the way we question, in the way we allow the vastness to reshape our sense of scale and purpose. And maybe that is the quiet message woven through all of this, that in a universe where almost everything is nothing, the small island of something, The stars, the planets, the minds capable of wonder, becomes immeasurably precious. We are temporary, but we are aware. We are fragile, but we can see the edge of time. We are small, but we can hold the universe in thought. And, in that sense, our moment under the stars is not diminished by the emptiness around us. It is elevated by it. For we live in the rarest chapter of cosmic history, a chapter when the night sky is still filled with galaxies, when physics is still written in the light that reaches our telescopes, when the universe has not yet pulled itself apart beyond recognition. And as we stand here, in the thin band of time when the cosmos is visible and alive, we are reminded of something deeply human. The universe does not last forever in this form, but the wonder it inspires, that may last as long as minds exist to feel it. And, in that fragile, luminous thought, the story of our almost empty universe finds its quiet meaning.